Okay, 1.1, radical expressions, rationalizing denominators. So what is rationalizing the denominator? Okay, this is to fully simplify expressions with a radical in the denominator. We must rationalize it and bring the radical to the numerator. Okay, this is the focus here. Okay, if you guys remember, a lot of times in 3U and then 4U functions, what ended up happening is in the textbook, if you looked at the back of the book for a solution, a lot of individuals would be like, oh, it's not 1 over root 3. Like individuals would be confused as to why it's root 3 over 3. And it's just because whoever made the textbooks just rationalized the denominator. Okay, so this is where, like, we're going to go over where they actually get those solutions, like those from. We're also going to go over something called a conjugate, which is going to come back, okay? And we're going to recall difference of squares. So lots of recall here. So this is the process of changing the radical number. So whenever you hear of the word radical, just think square root, okay? This is a radical. Okay, and what we're doing is we're changing the radical number to a rational number, which is an integer. Okay, so rationalizing one-term denominators. This is the easy one, okay? When the denominator of a radical fraction has an obviously fraction denominator, right, has one-term expression in the denominator, we must multiply both the numerator and the denominator by the same radical expression. Okay, so essentially what we're going to be doing is multiplying by a root of, let's go A over root A, right? If you think about this, all we're actually doing is multiplying by 1. And I put 1 in quotation marks. If we were like actually in class, I'd use my like fingers as in like 1. It is 1, but it's just going to make that fraction look a little bit different, okay? So we're not changing the number, okay? Example 1, rationalizing expressions with one-term denominators. So let's simplify 2 over 3 root 5 by rationalizing the denominator. So if we have 2 over 3 root 5, let's bring it here, 2 over 3 root 5, okay, what we're going to have to do is I look at this and I'm like, okay, there's a root 5 in the denominator. So what we're going to do is we're going to multiply it by 1. We're going to multiply by root 5 over root 5. Okay, so 2 times root 5 is just going to give us 2 root 5. And then 3 root 5 times root 5. Okay, so the 3 is going to be the normal number. We're going to bring that in front. And doing this the long way, root 5 times root 5 is going to be root 25. Okay, as a recall, we multiply the coefficients type of idea like by each other. So it's kind of like 3 times 1 would be 3. And then we can multiply the numbers under the radicals by each other. So root 5 times root 5 is root 25. Okay, and if you think about root 25, so we have 2 root 5. And root 25 actually simplifies to the number 5. So our simplified expression is 2 root 5 over 15. And then that's it. So just to review, if we have root of a number, let's say root 3, and then we're multiplying it by root 3, root 3 times root 3 is just going to equal 3. And I'm going to actually show you how to do this with exponent laws because this is going to be another little bit of a review. So root 3 as a radical, because this is a square root, right? We could technically write a 2 here. If we can't see a number here, it's going to be a 2. Okay, it's going to be a square root. Okay, so rewriting a radical of like a square root is going to be like 3 to the exponent 1 over 2. Okay, so if we had 3 to the exponent 1 over 2 times 3 to the exponent 1 over 2, what ends up actually happening with exponent laws is we would be adding these two exponents. This would actually be 3 to the 1/2 plus 1/2 which gives us just 3 to the exponent 1, right? Which is just 3. So that's where that comes from. So just be very aware that root 3 times root 3 just gives us 3. It changes our radical into a rational. Okay, now rationalizing two-term denominators. So when the denominator of a radical fraction has a two-term expression in the denominator, we must multiply both the numerator and the denominator by the conjugate. Okay, what is a conjugate? This is not going away. This is going to come back in limits. Okay, conjugate is an expression. So an expression with the form root a plus root b would have the conjugate root a minus root b. All that's changing, like the first and the second term are the same. All that's changing is that middle sign. So from positive to negative, or if you had root a minus root b, the conjugate would be root a plus root b. Okay, all that's changing is this sign. Okay, and again, what we would be doing is we would be multiplying by 1. Okay, but it's actually going to look like root a plus root b over root a plus root b, something like this. Okay, but this number here is actually 1. By multiplying this, again, we're just making that our number look a little bit different. So let's recall difference of squares. So let's go ahead and expand these. So by using foiling, if we had a plus b, a times a minus b, a times a is a squared, a times negative b is negative ab, b times a is plus ab, and b times negative b is minus b squared. When we go ahead and simplify this, these two middle terms end up canceling out, and we're left with a squared minus b squared. Okay, in functions, we really focused on going from this expanded value back up to the factored form, but now we're going from factored form to the expanded value, just to recall a difference of squares. Okay, so the same thing is going to happen with radicals. So root m times root m, what we're going to get is we're going to get root m, and that's going to be squared. Okay, root m times negative root n is going to be negative root mn. You can either write it like this, so root mn is the same as saying root m root n. That's the same. Okay, root n times root m is going to be plus root mn. I'm just putting them in alphabetical order. And then minus root n times root n is going to be our root n, but that's going to be squared. So let's go ahead and simplify. Negative root mn and positive root mn cancel out. Okay, and we're left with root m squared, but this root and this squared actually cancel out. Okay, the long form of this, m would be raised to the 1/2 if we wrote it as an exponent, and this would be squared. And we know power of a power, 1/2 times 2 is just 1. So we were left with m. And now minus, so this root n would actually be written as n to the 1/2 and then squared. Again, 1/2 times 2 just gives us 1, so m minus n. So m minus n is the expansion of this right here. Okay, so just note, by multiplying by the conjugate, there are no longer any radicals. Okay, it's going to look like this. So that's what we do when there is a binomial in the denominator. Example 2, rationalize expressions with two-term denominators. So let's go ahead and simplify 2 over root 7 plus root 5 by rationalizing the denominator. Okay, and by the way, fully simplified is like, it is when there are no radicals in the denominator. So let's go ahead and rewrite this. I'm going to write it over here so we have lots of room. Okay, 2 over root 7 plus root 5. So we have a binomial in the denominator. So we know that we have to multiply it by the conjugate. Well, we're multiplying by 1, but it's going to look like a root 7 minus root 5 over root 7 minus root 5. I'm going to get rid of this question here. We have the entire board. Okay, so if you think about it, this is a binomial, so we can just bracket these because we're going to be using distributive property. So here we can do 2 root 7 minus 2 root 5. Okay, all over, and we're going to FOIL these. So root 7 times root 7, I hope we're okay just going straight to 7. Then root 7 times negative 5 is going to be negative root 35. Because these are both radicals, we just multiply the numbers. Root 5 times root 7 is going to be plus root 35. And then root 5 times negative 5, I hope that everyone's comfortable just going minus 5. Okay, so negative root 35 and positive root 35 cancel out. Because remember, this is a difference of squares. So let's rewrite 2 root 7 minus 2 root 5 over, so now we have 7 minus 5. You can rewrite it and then simplify it in the next step. I'm going to go ahead and simplify it right now. So I get 2. Okay, so in that first step, I probably shouldn't have, like, I can see this, but I probably shouldn't have distributed that 2. I'm going to refactor out this 2. Okay, so I'm going to factor back out the 2. So we have 2 root 7 minus root 5 in the numerator over 2. And then those 2's can cancel, and I get root 7 minus root 5. Example 3, simplify the radical expression 4 over 2 root 5 minus 4 by rationalizing the denominator. So let's start with 4 over 2 root 5 minus 4. So the denominator is a binomial. So we're going to go ahead and multiply this by the conjugate. Okay, but we're multiplying by 1. So we're going to put the conjugate in the numerator and the conjugate in the denominator. So we have 2 root 5 as the first term. And instead of minus 4, we're going to go plus 4. Okay, and all of these are going to act as binomials. So let's leave the numerator for now. Let's go 4 bracket 2 root 5 plus 4. And let's expand the denominator. So 2 root 5 times 2 root 5. Remember, the numbers are going to multiply like normal numbers. And then the radicals are going to multiply. So we can skip by writing root 25, right? Root 5 times root 5. And we can just simply write times 5. Okay, the next one, 2 root 5 times 4. So we're going to go plus 8 root 5. Right, 4 is the normal number, 2 is the normal number, so 8 root 5. Minus 4 times 2 root 5 is going to be minus 8 root 5. And minus 4 times 4 is negative 16. Yeah. Right, because those are just normal numbers. Remember, those are not radicals, so it's minus 16. Okay, these two middle numbers, one's a positive, one's a negative, they're the same number, they cancel out. So let's leave the numerator as it is. We'll work with that in a second. And in the denominator, we have 4 times 5, which is 20, minus 16. So we have 4 bracket 2 root 5 plus 4. And then in the denominator, 20 minus 16 is going to give us 4. Okay, 4 divided by 4 just cancels out, and we're left with 2 root 5 plus 4. Okay, last one. Rationalize the numerator of this expression. So a little bit different, but just kind of expanding our knowledge here. Okay, so we have root 5 minus root 3 all over 3. So if we wanted to rationalize the numerator, which is not common practice, but again, just expanding our knowledge, we would look at the numerator, identify that this is a binomial. So we're going to go ahead and multiply by the conjugate. Root 5 plus root 3 over root 5 plus root 3. Okay, treat these as binomials. Okay, in the denominator, I'm just going to write 3 bracket root 5 plus root 3, and we're going to come back to that. But let's go ahead and expand the numerator. So root 5 times root 5 is just 5. Root 5 times root 3 is plus root 15. Minus root 3 times root 5 is minus root 15. And root 3 times root 3 is minus 3. Okay, these two middle terms can cancel out, and we're left with 5 minus 3, which is 2 over 3 root 5 plus root 3. I feel like fully simplified is going to be distributing the 3 into the bracket there. So I'm going to say fully simplified is going to be 2 over 3 root 5 plus 3 root 3.